Welcome back to a new Hack My Home video. Here we are with episode 2 related to presence management. In this second episode, we will talk about geolocation, beacons, and create the infrastructure for beacon detection inside our house. Let's start talking about geolocation, one of the fundamental basics to extend the presence system even outside your home, or to add an extra layer of reliability to the trackers we saw in the previous episode. Geolocation is what allows us to know if you are at home, outside home, or in any other place with a good level of accuracy. But how does it really work? To enable geolocation, you need to access the Home Assistant application installed on your phone, open the settings, and select the sensor management option, then scroll down to the geolocation sensors section. Tap on geocoded location and enable the sensor. Make sure the sensor updates every minute. Additionally, it is recommended to enable the high precision update interval, the high precision mode, background positioning, single accurate positioning, and finally, the location zone. After applying these changes on the smartphone, Home Assistant will automatically create a new sensor in the mobile app section. This sensor provides the device's geolocation and generates a tracker indicating whether the phone is within the area defined as home. The tracker is then linked to the person entity associated with that smartphone, allowing Home Assistant to accurately determine when that user is at home or away. Now we move on to another fundamental element for detection: beacons and Bluetooth Low Energy, known as BLE. Unlike GPS, which identifies the position on a map, BLE is used to understand how close you are to a specific point inside a house, and it does so very precisely with very little energy consumption. It is like a small digital lighthouse. It continuously sends out a low-power Bluetooth signal. A BLE receiver detects this signal, estimating proximity based on the strength of the received signal. The stronger the signal, the closer you are. This system is particularly useful indoors, where GPS tends to lose accuracy or stop working altogether. By placing some BLE receivers at strategic points in the house, we can estimate the position of the device emitting the beacon with great accuracy. Each receiver perceives the signal with a different intensity. By combining this information, we can determine which room the smartphone is in. In the example we are observing, the one placed in the living room receives it with the strongest power. This allows us to immediately understand that the device and therefore the person is located in that room. In this way, BLE becomes the perfect complement to GPS. GPS tells us where you are in the world, while BLE tells us exactly where you are inside the house. Before you can use a BLE receiver, you need to activate the beacon transmission. To enable it, access the Home Assistant application installed on your phone, open the settings, select the sensor management option, scroll down to the Bluetooth sensors section, and select the BLE transmitter. Enable it. Select the broadcast mode as balanced. Set the BLE packet transmission to only occur when connected to your home wireless network if you are sure of having good wireless coverage, and set the transmission power to medium. Write down the unique identifier of the BLE beacon, UUID, indicated in the settings. From this moment, the smartphone will start emitting a small BLE packet at regular intervals containing that unique identifier, which will then be detected by our BLE receivers distributed around the house, allowing us to understand in which room the smartphone is located. After applying these changes on the smartphone, Home Assistant will automatically create a new sensor in the iBeacon section. This sensor provides the estimated distance from the device, the signal strength, and its level, and generates a tracker indicating whether the smartphone's beacon has been detected or not. The tracker can be linked to the person entity associated with that smartphone, allowing Home Assistant to understand, based on the beacon's status, when you are at home or away. Like BLE receivers, in this case, transmission powers are very low, and the signal range is limited and easily affected by walls, furniture, and interference. For this reason, it is recommended to distribute proxies around the house, which are small devices like ESP32s that collect BLE signals in various rooms and forward them to Home Assistant. Fortunately, we can integrate the proxy and BLE receiver functionalities into the same device. This way, we are no longer dependent on the coverage of a single smartphone or a single receiver. Each room has its own listening point, and presence detection becomes much more accurate and reliable.
To create a BLE receiver capable of detecting beacons and having Bluetooth Proxy functionality, one of the best components to use is ESP32. I recommend the ESP32C Mini. It is small and can be placed anywhere, requiring only a 5-volt power supply via a USB Type-C port or direct connection to the VCC and GND pins. This microcontroller already integrates a BLE radio, so no additional modules are needed. Just power it, load the firmware, and it immediately becomes a small BLE detector that can be installed anywhere in the house. Its operation is simple. The ESP32 remains in listening mode and detects all BLE packets passing nearby. For each device found, it verifies that the beacon's unique address matches the smartphone's and records the signal strength and estimated distance. Sending this information to Home Assistant, we can use it to identify which room the device is in.
The link to the generic code to upload to the ESP32 can be found, as always, in the video description. Now let's look at the most important parts. Let's start with the configurable variables. This section is used to gather all the basic information that the ESP32 will use in the rest of the code. Here we define the device's IP address, its network name, the model of ESP32 we are using, and most importantly, the UUID of the beacon we want to monitor. If in the future we want to add other beacons, for example, Orions or other accessories, we can do so easily. Just create a new variable with a different name, and the ESP will be able to handle them all without problems. Now let's move on to the permissions section. This part of the code allows the ESP32 to behave like a true proxy. Essentially, it extends the signal coverage and helps Home Assistant better detect all the BLE devices present in the house. Immediately after, we activate the actual BLE scan. Here, we specify how often a new scan should start, in our case, every 300 milliseconds, and how long each cycle should last, which is 30 milliseconds. Additionally, we enable the active scan mode, which is more accurate and much more responsive. These settings are particularly effective when we want to quickly detect people's movements between rooms, updating the status almost in real time. Now we move on to the sensor section. Here we enter the heart of the system. Whenever the ESP detects an iBeacon with Aura's UUID, it performs 3 fundamental operations. Records the RSSI value, which is the received signal strength, stores the exact moment the beacon was seen, and sets the beacon's state to true, indicating that Aura is present and transmitting. Starting from the RSSI value we have just measured, we apply a logarithmic formula that allows us to estimate the distance from the beacon. The result is a measurement expressed in meters that gives us a fairly accurate idea of how close or far Aura is. This latest sensor allows us to know at any moment how many seconds have passed since we last saw the Aura beacon. The operation is simple. It takes the time of the last sighting, compares it with the current time, using the millis function, and returns the difference in seconds. Basically, it answers the question, how long ago was Aura last seen? This data becomes extremely useful for creating truly intelligent logic. It is a small sensor, but it adds a huge amount of precision to indoor localization. We have reached the end of this second episode. In this video, we have seen how to add geolocation and beacons to the person entity, and how to create the infrastructure for beacon detection inside our house. In the next episode, we will see some automations to better manage the BLE detectors and beacons, and how to create a dashboard to display all data.
If you liked this video, leave a like, it's free for you and a huge help for us to grow the channel. And if you want to support us even more, share the video and write in the comments what you'd like to see in the next episode. Let others discover how fun building your own smart home can be. Subscribe so you don't miss the upcoming experiments, guides, and ideas. See you soon from Aura and Orion.